Okay, one store sells sandwich meats for this much per 3 kilograms, the other in that much per pound. Which store is cheaper? Okay, so here's the situation. I can't do a comparison because, first of all, I'm comparing kilogram stuff with pound stuff. So what do you want to do? Would you like to move this into pounds, or would you like this to be into kilograms? And it doesn't matter. You just have to pick. What do you want to do? Everything with kilograms or everything with pounds? Somebody pick.
Pounds.
Pounds. Okay, so I'm going to take this and I'm just going to take the 3 kilograms and I'm going to change it to pounds, and LBS is the pound symbol. I looked it up once, something with Latin. Okay, so there is what I want to know. But underneath it tells me 1 kilogram is 2.2 pounds. So I would times, and that should be with, even out my calculator I can do that timesing. 6.6. Okay, so now that's good. That's in, so forget the 3, it's 6.6 pounds. Okay, so 76.65 for 6.6 pounds should cost me how much money for just a pound? That's what I'm going to do. That's be a unit rate. So do you know how to do that? Multiply, divide situation, right? So that is the unit rate there versus 23.50 for 2 pounds would be how much money for 1 pound? Okay, and you do on your test need to answer the question, or else you're going to lose a half a point, because this is about figuring out which store is cheaper. That's the actual question, so make sure you answer it. So I need you to indicate somewhere the answer. So this one is obviously cheaper. Or you could have circled here and said this is cheaper. Somewhere, just indicate to me. Two racers from different towns wanted to see who's faster. The first racer reported that she ran 5 kilometers in 38 minutes. The second went 3 miles in 0.4 hours. Okay, so I have all kinds of things going on here. The first thing I'm noticing is somebody did kilometers and somebody did miles. I can't mix and match. So again, what do you want to do? Do you want to make everything with kilometers, or do you want to make everything with miles? Miles. Okay, so we're going to change 5 kilometers to something in miles. Okay, and then you can use, I gave you some conversions here. You can use whatever. There's 2 conversions. 1 kilometer is 0.62 miles. Okay, Another problem. The first racer timed themselves in minutes and the second racer times themselves in hours. That's another mixed match. What do you want to do? Do you want to do everything with minutes or do you want to do everything with hours? What do you want to do? Because it doesn't matter. I can do both. Minutes? Okay. So therefore, this 0.4 hours, we got to make it into minutes. So 0.4 hours is how many minutes? When I'm not going to give you this, so you have to know this in real life. What do you know? Something. 60 minutes are inside 1 hour. Okay, now I'm ready to go. So when we said 5 kilometers, we actually scratched that off and are replacing it with 3.1 miles. So 3.1 miles in 38 minutes equals, do you know what's probably not going to be good if I do how many miles per minute? Do you guys understand a speed of a runner? That's really weird to do. Would you be okay if I did this for 60 minutes so that I can tell you how much they do per hour? Would that be okay? If you had done it per minute, you would have got such a weird small decimal number that it would have been hard to kind of even understand. Okay, as a runner, you should know that you probably don't measure your miles and kilometers per minute because you're going to go for a while. Okay, so the other one, do you remember what we did? We scratched off 0.4 and we replaced it with 24 minutes. Okay, so that person ran 3 miles in 24 minutes. So how much would they go in 60 minutes? Okay, now it's a good comparison because I have both in miles, both per 1 hour. I can look. So who is faster? So you have to also answer the question or you're going to lose a point. So who is faster? So I just need to kind of indicate somewhere that that speed would be faster. Okay, so I did a graph here, and it's a plane that's descending. That's what it is. It's going down to the airport. So this is in thousands of feet, and this is in minutes. So my first question, what interval is the plane descending the fastest? How do you know something is fastest according to a graph? What are you looking for? You're looking for steep. You're looking for something that's steep. So which part of this would be the steepest line? I would say C to D would be steeper than, right? A to B is a little bit more flat. what's going on the interval here from B to C? What's going on with the airplane? It's flat, so it's just not descending anymore. It's just staying. It's flying level. I don't know. There's probably a better flying term than that. And I actually want you to figure out the rate in this C to D section. Okay, so how much distance has moved in this zone? So from here to here, how much distance have you moved? So this had a height of 2,000 and this had a height of 0. So then it's 2,000 what are we in feet? How much time have we moved? So from here to here. So would you say that this one was at 35 seconds? And this one looks like it is at 45 seconds. So how much time, or minutes, sorry, that's 10 minutes. So that would be 200 feet per minute. Negative. 200 feet. Yeah, you could do two things there. That's a good one. You could write the negative 200 feet per minute is what it's moving by, or you could actually write the word descending 200 feet per minute as well if you wanted. Either one would work. Did I hit where you needed to? Okay, you know that you can type 300 words per minute, or not 300, 36 words per 1 minute. The teacher gives you the rest of class, so there was 41 minutes and 20 seconds left, to type an essay that was 1,000 words. Are you going to make it or are you not going to make it? Okay, so there's two ways you can do this. Okay, here's number one. Number one is you can see how many words you can type in this time. Or method two would be to see how long these words would take you. What do you want to do? It doesn't matter. They both would work. So I would probably say 1,000 words would take me how long? Probably what I would do. You can do it either way. Okay, cross multiply, divide. So, would you be able to finish that in the class time? Yes, because it's yeah, you can finish it because it's under the class time. Okay, just a side note, what would you do if you used 41 minutes and 20 seconds as a time? How could you write that for me differently? 41 minutes and 20 seconds. How could you write that as just one decimal number? What would you do? 41 decimal, it's not just decimal 2, because clocks don't run in hundreds. So what would you do to make that work? How many seconds per what fraction? $20 seconds out of 60. Do you see that? If I ever did have to use something like that. What if I made you convert this to seconds? So this could be 27 minutes and how many seconds? What would you do? How do I make this decimal into seconds? Everything with time is somehow using 60. So what do you want to do? You would want to times by 60 makes 47 seconds. Okay, got that with time? Please don't make decimals just what you see. You got to use 60ths. So 20 seconds is not 0.2. Okay. How would anybody go from seconds to hours? What would you do with seconds to hours? Seconds to minutes to hours. What would you do? You'd have to use a 60 and another 60. You'd have to go with a 3600. Okay, scales. So when you use scales, I always want diagram to real life. Always like that. That's how I want it. I always want a 1 in the scale. Okay, when I'm looking at this, which one is the diagram one? Which one's the real life one? The thickness of a coin, so that sounds like a real life coin. In the diagram, it was drawn like that. So there's my D, my R. Now, do you notice a problem? There's a mix going on. There's millimeters and there's centimeters. So what do you want to do? Should we change everything to centimeters, everything to millimeters? You want to do centimeters? I would probably do millimeters. It might be easier because it would make this a small number. Does anybody know the conversion number with millimeters and centimeters? What's the number? 10? 10 millimeters in a centimeter. Okay, so I times that by 10. So 29.25, 1.95. That was the diagram number. That's the real life number. They're all in the same units. Okay, which one of those do I want to change into a 1? Which one of them is a smaller? This is smaller, so I'm going to change the smaller one into a 1. And can you get me the last component of your cross multiply? So every 15 on the diagram was only 1 in real life. So the real life object was really small. Does that kind of make sense? Right? Because I kind of blew it up to draw it on the paper. Okay, a bedroom has a width of this, and on the diagram it was this. So there and there, which one is the diagram? Which one's the real? Okay, mix and match again. We got feet and inches. So what do you want to do? Should we go everything feet or everything inches? And I would pick everything inches. Would be a little bit easier. So again, I'm not going to put this number on the test. I think this one is one of them that you should know in real life. So in a foot, how many inches do you have in there? 12. So I'm going to times this by 12. Okay, so diagram to real. Diagram to real makes 18.75 to the real 150. And on a diagram, it's nice to have a 1 in there. So which number is smaller? You put that into a 1. So turn the 18.75 into a 1. Find the last component. So this means my real life is bigger, right? Obviously your bedroom is bigger than the paper, I hope. Unless you're like a mouse, I don't know. Okay, number 7. The thickness of a coin is this. Can you get me if that's an R or a D? What is that? The thickness of a coin. That would be a R. In the diagram, they used a scale of 50 to 1. So diagram to real life. They did 50 to 1. And then we had a real life of 1.8 millimeters. So what is the dimension you would put on the diagram? That's what you're figuring out, right? Do you see how it's all lined up? So times divide. So your diagram, you're going to sketch out, you're going to use 90 millimeters, or is there another way you could write 90 millimeters? And maybe in centimeters as well? What would you write it as centimeters? Just 9. Okay, a bedroom has a width of 9 feet. Would that be something that is a D or an R? What is that? That'd be a real life. The scale was 1 to 10. So the diagram to real was a 1 to 10. How many inches will you need in your diagram? Okay, so here's my question for you. Do you want to go about this with feet right now and convert to inches later, or do you want to just convert to inches right now? It doesn't matter. We can do either or. So do you want me to work with 9 feet and then convert my answer at the end? Or do you want me to convert 9 right now? Because either one doesn't matter. We can do it later if you want. Okay, so what do you get there? You get 0.9 feet. That's the diagram. But I need to figure out how many inches that is. Okay, so we were designing a bathroom and we used a 1 to 5. On the diagram, we drew the bedroom as a 15 by 16 inches on the paper. So what is this in real life? So I'm going to take this separately. Okay, so how many real life was the 15? So the 15 was really 75 in real life, and the 16 was really 80 in real life. Okay, but we gotta give them a foot/inches measure. So what are you gonna do here? So 75 inches is how many feet? How about we do that? When we know what? And you're gonna know this from your head. I'm not gonna give it to you again. 12 is 1. Okay, but that's not the answer. 6.25, I can't write that. So this is obviously 6 feet. And how many more inches would that be after 6 feet? Okay, so what else could I do here? Okay, so 6 times 12 inches is 72. So how many more inches do I have after 72? 3 more inches. Okay, repeat the process. So the room is 6 foot 3 inches on one wall. So the other wall is 6 point something something feet, so 6 feet. What did we say 6 feet was? We already just did that. 6 feet was 72 inches already. So how many more are we past 72? We're past it by 8 more inches. 72 plus the 8 is how I made the 80 inches. Building construction stuff. Anybody take woods in grade 9 or 10? Is this kind of like, would you have done stuff like this? Kind of with inches and feet. Okay, let's go one more question and then let's call it a day and do the other half tomorrow maybe. So a room is measuring 20 feet by 18 feet. And you are going to try to draw it onto a paper. You're going to try to make this room fit onto a paper with a scale. Okay, so this is called the real, right? And this would be my diagram. Would it make sense if I put the long 20, correlate it to the long 11? Does that make sense to you? Long side with the long side, the shorter side with the shorter side. Okay, you have a mix match. You got something with feet, you got something with inches. Not good. Can I do inches, inches? Would that work better, or feet, feet? Probably inches, inches would be better. So can you times this by 12? Okay, good. Now, can you tell me what the divider was between those sides? What would you have between those sides? 21.8 something? Can you also do the same with this? What kind of divider would you need to get that? Okay, so remember what we were doing. We're trying to shrink this enough to fit on the paper. So I have to use a number bigger than these because you have to shrink it enough that it fits. So for instance, if I used 24, I wouldn't be able to shrink this enough and it would be too much for my paper. So what do you want to pick? Do you want to go with like a 26? You can go with a 30. Doesn't matter. Just anything that's a little bit bigger than your divider numbers here. What do you want to pick? 26 or 30? 26. Okay. How do you write it with a diagram to real? Is it 1 to 26 or 26 to 1? What's the small and what's the big? The diagram is small and the real life has to be big. Okay, I'm just going to extend this question. If you use that scale, what would your drawing look like on the diagram? So can you divide this by 26? That's what you told me to use. Well, that got me to 9.23, so that fits on my paper. And then the other side would end up being 8.31. And look at that. What I want to draw would fit inside my paper. And that's what you would be doing in real life as an architect, as a designer, right? You'd be fitting it onto a paper.